Thank you, Anita, and thank you, everyone. I'm Henrik, and I'm going to tell you about TRUUST Neuroimaging. At TRUUST, we are making a cloud-based software service that dramatically increases what we can see in the brain. Our product transforms the existing install base of EEG equipment and enables true biomarkers for the first time. So the problem that we are addressing is that brain disorders and brain disease pose a huge challenge that is likely to affect most of us. And up until now, we've really been unable to do much about it because we don't understand the brain. But why don't we understand the brain? Well, the main reason is that because we can't see it, we can't actually study it. We can't understand what we can't see. There's a huge blank space in the map of what we can see with different neuroimaging techniques, because none of them have high resolution in both time and space. And the true functional window to the brain lies in this blank space. The consequence is that the cost of brain-related health problems is enormous, and it's growing at a catastrophic rate. This translates into a neuroimaging market, which is already of the order of billions. So how can we reduce this cost and capture a large part of the market? We've had the key insight that current EEG analysis throws away most of the available information as if it was noise. We have, however, figured out how to treat the recorded data as a compressed hologram and computationally search for the best decompression with the least noise. In general, a very difficult problem with many local minima, but one that we can transform into a much simpler optimization problem using prior knowledge of the brain. The result is a true functional window to the living dynamic brain. So let's take a first look through this window. This is a video of our second generation prototype visualizing electromagnetic energy flow in the brain at unprecedented resolution and detail. Energy flow is a completely new measure that directly reveals how different areas influence each other, because if energy is flowing from A to B, it means that A is influencing B. And this is something that is actually there. It's not based on statistics, as is currently done. This new view of the brain will greatly help us understand it. And people love it. Even the experts. It's not only useful, it's also quite beautiful. And just to highlight that this is a dynamic view, here's what happens when we show a picture of a face to a participant. You can compare this to the conventional source analysis of the same data. It's static, it's low information, and it's a simple mapping onto a generic brain model. Clearly, the information content here is orders of magnitude above anything ever seen before. And it immediately raises the question, now that we can see it, what are we going to do with it, and how is it going to change the world? Imagine that these images represent what we've been able to see in the brain up till now. We can't really make sense of them, and neither can computers. What we have done corresponds to doing this, taking the information quality to the level where even computers are able to recognize and caption what are in the images. This is a real machine learning example from Stanford. So what we're proposing is to do the same thing for energy flow imaging, automatically discovering biomarkers for brain-related health problems. That means early diagnosis of Alzheimer's, localization of epileptic focal points, diagnosis of autism, and tracking of concussions and traumatic brain injuries, and so on. And we can take this even further, revealing not only what is there, but also where it is, which is really important in the brain. So, we envision a future with an EEG cloud terminal in every doctor's office as a natural part of every physical. And the doctor doesn't even have to be an EEG expert when using our biomarker assistant. To get to this point, we are partnering with key opinion leaders in high-profile research labs. And we are on track to deliver a solution tailored to specific conditions of high impact by the end of the year. From that point, we'll switch to the cloud so that we can scale and deploy quickly through existing channels. This software service will be the focal point of all data that pass through it, including historical data, and it will allow us to set up a positive feedback loop whereby data mining generates relevance for more people, which in return generates more data to mine, and so on, ultimately making EEG biomarkers relevant for general population health. Our team is myself and my co-founder Lars, and between us we have many of the skills needed, all across neuroscience, physics, design, and engineering. But to fully implement our vision, we need to expand our team, and for that purpose, we are raising an initial seed round of $2 million. Thank you.